Okay, here's the experiment which debunks the greenhouse effect. Greenhouse effect of carbon dioxide. Debunks carbon dioxide as a greenhouse gas. We've all been told many times that carbon dioxide is a greenhouse gas which traps heat and causes global warming. So can we test that? Yes, we can test that very easily. This experiment has cost me so far less than £5. These little thermometers are fish tank thermometers from a tropical fish supply shop. Cost about £1.50 each, and of course a bottle of mineral water, sparkling mineral water, carbonated with carbonic acid, costing about 50p to buy. So there you have it. AGW, anthropogenic global warming, carbon dioxide greenhouse gas theory, debunked for £5, less than £5. So this experiment will set out to do that. Okay, so we've got 3 empty plastic bottles. One is dry, a dry bottle containing nothing but air. That one will stay as it is. But firstly, I will just make sure the lid is tight. Make sure that lid is done up very tight. And I'll just write on the label here, dry air. Okay, we can read that, can't we? We can read that one, dry air. So, you can see how sensitive the thermometer is, because just by holding that bottle for a couple of seconds, the warmth from my hands has increased the temperature by 4 degrees from 18 to 22, and now you can see it falling back slowly. That's how sensitive these thermometers are. They're for this purpose excellent little devices. And what we're going to do is we're going to take the temperature in each bottle up above 30 degrees, the uppermost reading on the thermometer, and what we're going to do is monitor the temperature as it falls to see which container retains most heat. This is an undeniable experiment, and will show whether CO2 is more efficient at holding on to heat than just ordinary air. Now, in the CO2 bottle, we're going to half fill this bottle with carbonated water, and then we're going to shake it up. And as the CO2 is supposedly heavier than air, which it is when it's at low temperature, it's heavier than air. So the CO2, the pressure of the CO2 will compress any air that's left in the bottle up to the top, and then we will release the bottle top and allow that air out. So what we end up with is a cavity of pretty much pure CO2, which is way and above what we will have in the atmosphere. So what we'll be testing is pure CO2's ability to trap heat, to hold on to heat, and we will test that by squashing out any other air, and in here we will just have a pressured container of CO2. So just because of what I've just explained, I'm going to write pure CO2 and water. There, can we read that? So, yep, pure CO2 and water. And in the middle bottle, I'm just going to put ordinary tap water, halfway, the same level as the carbonated water, and just ordinary air. So tap, can we read that? You have to excuse my handwriting, it's not the best in the world, but it will do. Tap, water and air. So the control is the empty bottle of dry air. That gives us our control because we've got the dry air, we've got the water and air, and then we've got the water and CO2. So we've got a cross control there, which shows that we can't say, oh well, it's the water, you know, it's because of the water, or it's because of this, because of that. That's why I'm using 3 bottles, so that we get a fair experiment and people can't pull me up on anything here. So really, this should be a defining moment in the AGW debate. So there you go. And let's just let those thermometers just all try and equalize a little bit. Well, let's put the water in first. So we'll put some tap water in the middle bowl. Half full. Let's just, so you can see it's ordinary tap water. It's going in there. Okay, I might just want to put a little bit more in there. Looks, could you fetch me a little bit more tap water this way? Okay. I'm going to send my assistant off to the kitchen sink. And just pull back here. As you can see, all the thermometers are around about equal. Thank you. I just want to top that bottle up so we're sort of about half full. There we go, some fresh tap water. About halfway. There. Now, what I'm going to do is I'm going to decant some of this sparkling water into the jug and then pour it into the CO2 bottle. There you go, you can see that is very fizzy, very carbonated, and that will pressurize the CO2 bottle